Welcome. In this session, I will give a general overview of the chain rule for partial derivatives, functions of several variables. First, let's look at a special case. Let f be a function of two variables x and y, where x and y are themselves functions of a variable t. By substituting these functions into f, we can consider f itself as a function of t. So now we want to express the derivative of f as a function of t in terms of partial derivatives of the function f with respect to x and y, and of derivatives of x and y with respect to t. So you need to do the difference quotient. So we change t by a small amount, say dt, and that changes f to some new value. Eventually we are going to calculate the difference quotient, but let's use the differential approximation to rewrite this. The differential approximation for one variable now applied to x as a function of t rather than f as a function of x of t plus dt is x plus dx, and dx is dx over dt times dt. Same kind of thing for y. This gives us this first step. Now we use the differential approximation for functions of two variables, which we talked about earlier. That's this. So the change in f due to the changes in x and y is given by this part. We are going to apply this to changes here. Since x changed by dx over dt times dt, it causes f to change, and that change is approximately the partial of f with respect to x times change in x. There's a change also due to y, and that's approximately the partial with respect to y times the change in y. So altogether we see that this is the change in the function f. So if we take this change and divide it by dt, we get this difference quotient, and that gives us this quantity. We can show that in the limit this approximation becomes exact, and in the limit this is the derivative of f with respect to t. This gives us the chain rule for this case. This can be extended to any number of variables. So if f is a function of x, y, z, so on, and these are all functions of variables r, s, whatever else, then by substituting for x and y and whatever else, we can think of f as a function of r, s, etc. Then df over dr will be df over dx times dx over dr plus df over dy, dy over dr plus etc. One term for each variable. So you can think of it like this. If there was just one intermediate variable x, this is the old chain rule. But if you have several intermediate variables, then you get a contribution for each variable that looks like the old chain rule, and then you take the total contribution, add up the contribution with respect to each variable in the middle. That's the final chain rule. In the next session we will see how to use this for calculation.